eighth graders, it's Mrs. Thompson. We're going to get into section 4.9 today, and we're just going to focus on example 1, identifying parallel lines. That's our goal for today. Now, one thing I want you to focus in on is a definition of parallel lines, and here it is. I've bordered it for you so you could see it, outlined it. These are lines that lie in the same plane, but they have absolutely no points in common. So in other words, they do not intersect. They do not intersect. They will never intersect. Parallel lines will infinitely be the same distance away from each other. Now here are 3 different scenarios. First scenario, you could have 2 different non-vertical lines that are parallel if they have the same slope. That's important. Same slope is really, really super important. Also, here's a second scenario to consider. If you have vertical lines, they're automatically parallel to each other because they all have the same exact slope. Their slopes are all undefined. So that's the same slope, so that means all vertical lines are parallel to each other. And then you've got this third scenario. All horizontal lines are parallel to each other because they all share the same slope of 0. Not to be mistaken with no slope. 0 is actually a number, and no slope just means there's not a number on this planet that could be used to define that slope. So we consider vertical lines to be undefined, have undefined slopes, and horizontal lines have a 0 slope, or slope equal to the number 0. Okay. There's one more point of clarification. I don't think your book made a good enough or strong enough endeavor to help you understand this. But when we're dealing with parallel lines, yes, they have to have the same exact slope. They have to share that. But they also have to have different y-intercepts. So I'm going to put that really big, make that very clear to you, okay? That parallel lines do indeed have the same exact slope, but they have to have different y-intercepts. If they end up having the same y-intercept and the same slope, then what you have there is the same line. It's a line graphed on top of itself. And the same line graphed on top of itself technically does not mean that they are parallel. So that's an important thing we need to look at when we're considering it. Okay? So let's start. Your book actually had example 1 graph, but I wanted to remind you how to do this graphing. And so I'm going to start right here. I'm squiggling y equals 4/3 x plus 3, and I'm also going to squiggle y equals 4/3 x minus 5. First of all, they are both in slope-intercept form. Perfect. The reason is because we can clearly identify the slope and the y-intercept. And we can do that for both of them. And notice that they follow what I just said. They have the same slope. Both of them have slopes of 4/3, but they have different y-intercepts. The first one crosses at +3, and the second one crosses at -5. And so I'm going to start with the +3. I'm going to find +3 on the y-axis, and then I'm going to go up 4, and then right 3. And I'm going to mark it, and there's my first line right there. So y equals 4/3 x plus 3. And then I'm going to do it again for -5. And I just wanted to show you, start here at -5. 1, 2, 3, 4. 1, 2, 3. Here it is. I just wanted to show you that they're going to lean the same way. And if I extend them either direction, they're never going to crisscross. They're going to stay infinitely the same distance apart. So these are parallel lines. Let me change colors because I want to talk to you about these next 2. I know there's something special about both of these. They are special lines because neither of them have an x term. So do you remember from a while back, if there's no x term, what kinds of lines never cross the x-axis? This is the x-axis right here. What kinds of lines never cross the x-axis? And if you said horizontal, you are absolutely right. These are horizontal lines. They are special. So if the x is missing, it's a horizontal line. That means no matter what I plug in for x, y will always be 2, as is the case in this first line. So here's the horizontal line, y equals 2. And no matter what I plug in the second line for x, y is always going to be -3. And so they both have the same exact slope. They have a slope that's equal to 0. And these are special, they're horizontal. So all horizontal lines are going to end up being parallel to each other. So if we just kind of sum it all up, I'm going to change colors again. We'll sum it all up. Here's our parallel lines. And we're saying y equals 4/3 x plus 3 and y equals 4/3 x minus 5. Those are parallel. And then our second set would be y equals 2 and y equals -3. Okay, so we actually had 2 sets of parallel lines in these 4 given equations. All right, let's flip the page. We're not going to graph this time. I'm sure some of you are going, yes, I'm happy for you. But we are going to have to identify in each of these equations both the slope and the intercept. It's not good enough just to focus on the slope. All right, so the first one's in slope-intercept form. That's perfect. We got m is 3, b is 2. That's perfect. Second one's in slope-intercept form. M is -1/2, b is 4. Okay, so far no parallel lines, but keep trucking. Now this is standard form. That doesn't tell us anything, so off to the side, let's rearrange this into slope-intercept form. Now remember, your goal is to get y by itself. That's your whole goal. So your very first step is take away x from each side, then divide everything by 2. All right, so now it's in slope-intercept form. That looks wonderful. And now we can identify, okay, this slope is -1/2 and the y-intercept is at -2. So already I'm seeing some good possibilities for parallel lines. All right, the last one here, that's in point-slope form. Now that tells me the slope, but it doesn't tell me the y-intercept, but I need both. So remember what we learned in previous lessons, you are going to do 2 steps. This is always the same 2 steps you follow when turning point-slope into slope-intercept. First, distribute. Okay, so that's going to give me y minus 5 is equal to 3x minus 3. Then get y by itself. Okay, did it. And I've got y equals 3x plus 2. So that means this one has a slope of 3 and a y-intercept of 2. Now as I stand back and I'm assessing my parallel lines, I am looking for same slope, different y-intercepts. And guess what? These 2 meet the criteria. So my parallel lines are going to be y equals -1/2 x plus 4 and the standard form x plus 2y equals -4. Those are definitely parallel. But what we notice about these 2 in particular, notice that they have the same slope, same y-intercept. Well, guess what? They're the same line. When they share both characteristics, same slope and same y-intercept, you have the same line. So these are not parallel at all. They're just the same line. They just look different because point-slope form does look different than slope-intercept, but once you rearrange it, you can clearly see it's the same line. Okay, if you have any questions about that, please bring that to class and let me help you tomorrow. Write your questions in the margin. Thanks for participating.